All right, so what I'm going to do is I'm going to go ahead and give you a tutorial on stoichiometry, but we're just going to cover mole to mole and mole to mass types of problems. Okay, so you should be watching this video as a result of me not being there, and you can always refer back to it. Okay, so we're going to do all these problems based on this particular formula. It says in a combustion reaction, acetylene, which is C2H2, combines with oxygen to form carbon dioxide and water. Okay, we're going to go ahead and use these to answer all 5 of our questions today. Now, I'm going to go ahead and work on number 1 as well as number 2. You're still accountable for it. You still have to write down what I'm writing down, but 3, 4, and 5 are going to be where you go solo. Okay, so let's go ahead and get started. All right, so the first one is asking how many moles of oxygen are needed to produce 8.25 moles of water. So if you have your foldable, the first thing you have to do is figure out which tab of notes are you going to be using. Now, your given is moles. And I'm going to go ahead and write a G, so that's your given. And they want me to find moles. And I'm just going to put an F as that's what I need to find. So it's a mole to mole problem. Okay, and that's exactly what the tab I'm going to use. All right, so as you look at your foldable, you'll see that your setup looks something like this, where it says a given moles of A, and diagonal you're going to have the number of moles of A, where that pound symbol is referring to the coefficients, and then right on top it's going to be the coefficient for the mole of B, which is the substance that you're trying to find. Okay, so I'm going to go ahead and get started by, first of all, drawing the dimensional analysis chart. Okay, so you start by going ahead and putting the given first, which is 8.25 moles of water. If you guys don't understand or know what the symbols for these compounds are, I went ahead and put arrows to point at what the symbols were for that compound. Okay, so we're going to write that right there. Okay, so here we go. We have 8.25 moles of water. Just like we did with the dimensional analysis for the conversions earlier for the first 3 weeks of this 9 weeks, we're going to make sure that whatever this is going to be the same diagonally. So this says moles of water, therefore that has to be moles of water. Okay, you're also going to have to be aware of what you're being asked to find. So we know that this is moles of water because that canceled diagonally. If you look at, again, your foldable, you'll find out that both of these are going to be moles. These are your molar ratios. So therefore, I know that this is also going to be moles of, and you're going to question yourself, well, moles of what? How do I know that? Because you're looking at what they're asking you. It's asking how many moles of oxygen. So you're always going to be given in these problems 2 substances. In this case, water and oxygen. Since you already used water because that diagonally canceled, automatically you can say that the other symbol is going to be oxygen. So in this case, our symbol for oxygen is O2 because it's a molecule or a diatomic molecule. Okay, so we're still missing what the numbers are. Okay, and if you notice here, as you would in your foldable, these are going to be found by looking at the coefficients for those substances. So since I'm using water, I'm going to look at the coefficient for water, and it's a 2. So therefore, I'll put a 2. And then for oxygen, the coefficient is 5. So therefore, this is going to be a 5. Okay, once I do that, I know that for my foldable, I've pretty much finished the steps that are required, and all I'm going to have to do is the math behind it. Okay, any number that is side by side, they're on the same level. So in this case, they're both on the top. You're going to go ahead and multiply 8.25 times 5, and then you're going to divide that by 2. All right, so the calculation after the calculation, I know that the answer is 20.63. And again, if you didn't catch that, it's when I multiply 8.25 times 5, and then whatever that is, that answer, I'm going to divide by 2. Okay, I can't leave the number just like this. I have to have a unit in my answer. So just so you remember, because these are diagonal and they're the same unit and substance, they cancel each other out. So once I do that, the only remaining unit I have is going to be moles of O2. The unit that you're going to use for your answer is always going to be on the very last box on the top. So I know that this is going to be moles of O2. And if you notice, that's what you're answering, how many moles of oxygen are needed. And that's what you would answer here. Okay, so now we're going to go ahead and go to the next one. And you're going to find that it's not the same type of problem. So here, we're going to notice that our given is moles. And they're asking us to find mass. Okay, so this is a mole to mass problem. And you're going to go and flip to your foldable to where it says mole to mass. All right, so on the foldable, you're going to find out that this is a setup for a mole to mass, where you're going to be asked to place given of moles, do a ratio step. And when I say ratio step, it's the ones where you use the coefficients, one for one compound and one for the other one that you're trying to find. And then a molar mass, which means you have a 1 mole and the molar mass of the compound you're trying to find. Okay, so notice that you also have an additional step, unlike for a mole to mole. So it's just adding a little bit more. Nothing too bad. So I'm going to go ahead and draw these 6 little boxes. Okay, so here we go. 6 little boxes. So I'm going to start with my given. My given is the only one that has a number value. So in this case, I have 3.70 moles of acetylene. So I don't expect you to know acetylene, but I do expect you to be able to look at the equation, the written equation, and see that it's pointing to this structure. So I know that the symbol for acetylene is here. Okay, so here's a 3.70 moles of acetylene. Remember, the same way we did it here, where this has to match that, we're going to do the same thing here. So it says moles of acetylene, so we're going to go ahead and cross this into this step diagonally and write down moles of acetylene, or C2H2. Okay, so you can refer back to your foldable, and you're going to see that it says the number of moles of A. A represents whatever the substance was in the given. So since this is acetylene, this is going to be acetylene. But notice that this says B. So that means it's going to be the substance that we're being asked to find. So it's asking us to find mass of carbon dioxide. So therefore, this is going to be moles of CO2. How do I know it's CO2? Because I look at the equation, carbon dioxide. Here's a formula it's pointing to. Not only that, but we've already learned this at this point where we should know what the formulas are. Okay, so now all we are missing is the numbers to the moles. So anytime you have a step where it's moles and on the top and moles on the bottom, automatically that should tell you or indicate that you're going to use the coefficients. Okay, just like we did here. When it's moles and moles, you're using the coefficients. We have moles and moles, we're using the coefficients. So CO2, the coefficient is 4, so therefore I write 4 here. And for acetylene, which is C2H2, the coefficient is 2, so therefore I write 2. Okay, so now that matches this, and so they cancel. Notice I'm not canceling the numbers, I'm just canceling the unit and the substance. So they're asking me for mass of carbon dioxide. Obviously, this would give me moles of carbon dioxide. That's not what I want. So now I have to convert these moles into mass. And to do that, I'm going to use a molar mass of carbon dioxide. Not only that, but I'm looking at the notes in the foldable. And remember, this will guide you. It tells you it's going to be 1 mole of B, which re-established that that's carbon dioxide. And right above it, it's going to be the molar mass of B, which again, carbon dioxide. Okay, so here's what it'll look like so far. Keep in mind that the molar mass is something you're going to hear quite a bit. Okay, they're not giving it to you. That's something you're going to have to figure out. You're going to have to calculate the molar mass of carbon dioxide. So that's what you do next. Okay, and just a refresher, here's carbon dioxide. Here's how I calculate the molar mass, just like we've learned in the past, and we know that's 44.01. It says grams per mole, which is why you have grams here, and this is your per mole part. So we're going to go ahead and write the 44.01 for our molar mass. Okay, so if you notice, we've completed the steps. We completed this, and this. Remember that anything under the given is going to be blank. So now all we've got to do is a math. So if you didn't remember from the one before, all the top numbers are going to multiply. So 3.70 times 4 times 44.01. You're going to multiply all the bottom numbers. 2 times 1. So whatever the answer is for the top number will always get divided by whatever the answer is for the bottom number. So we'll go ahead and do that. All right, once I do the math, I end up with 325.67 grams of CO2. I know I didn't mention this, but I'm going to mention it now in the video. Go ahead and round your answers to nearest hundredth. That means 2 numbers after the decimal point. Okay, so I've got grams of CO2. That's always a problem in class where you're like, so what's a unit? What do I put at the end of the number? Guys, remember what I said on the first one? Whatever the last box is at the top, that unit and substance is what you're going to write behind the answer. So why does that happen? Because these are like units. They cancel, and all you have left over is grams of CO2. And by the way, they're asking you a mass of CO2, and you're answering the question. Okay, so this is how you do a mole to mole. This is how you do a mole to mass. Okay, just to be on the safe side, it wouldn't hurt you to write down that this is mole to mole, just so you remember, and indicate that this is mole to mass. And now when you do these other three, based on what you're doing, you can use that not only as an example, but a way to guide you along with your foldable. Okay, so make sure you turn this in before you leave today.